Hello everyone, this is a video solution for the question 1 in tutorial 4, which is about ideal gas. Okay, so question 1 is asking us to calculate the mass of nitrogen, and we have got the volume of the nitrogen and also the pressure and also the temperature of the nitrogen. So basically what we need to do is actually to use so in the formula sheet we have a couple of equations here for ideal gas. Okay, so what I recommend you is that we just focus on these two. Okay, these two equations. The first one is PV is equal to mRT, and then we need another equation to calculate the R in here by using R is equal to R0 divided by the M. So R0 is called universal gas constant, and M is called the molar mass of a specific gas. Okay, so now what I'm going to do is I'm going to write both equations down here, which is PV is mRT and R is equal to R0 divided by the molar mass. Okay, so for the gas of nitrogen, the molar mass M is given in the above table, so it's 28. And R0 is a constant. It's also given in the question, okay, which is 8.314 kilojoule per kilomole K. So what I'm going to do is to use this equation to calculate the R, which we call it specific gas constant for the nitrogen. So now first of all I'm going to calculate R, which is equal to R0 divided by M. So R is 8.134. So the unit here I'm going to also write down here, so just to make sure we check all the units, divided by M. So for nitrogen M is 28. Okay, so if we calculate that, then we will get the value of that R is 0.297. Okay, so we can calculate the unit as well. So kmol and kmol has been deleted. So we've got kilojoule per kilogram K. Okay, so once we calculate the value of R, now we'll be able to calculate the mass. So depending on the equation here, PV is equal to mRT. So what we need to calculate is the mass here. Okay, so the mass M is equal to, I'm just going to divide RT on both sides. Okay, so what do I get? PV divided by RT. Okay, so what we need to do is just to put all the values of all these variables inside this equation, but be very careful about the units we are going to use. So I'm going to recommend you to convert everything to SI based units. So for pressure, we have got 265 bar, so it's in bar, so we need to convert that to Pascal. So at the top I've got 265 times 10.5 times V. V is volume, so have a look at the volume. Volume is in liters. Okay, so we need to convert that to cubic meter. So 75 times 10 minus 3. Okay, that's because of 1 cubic meter is 1000 liters. Divided, okay, R here. So we have already calculated R here, but be very careful. Actually, this is a very common mistake. That unit is in kilojoule, and then we need to convert that to joule because kilojoule is not actually a SI based unit. So we need to convert by times 1000, so that we'll get joule. Okay. So one more thing is about the temperature here. So we need to use Kelvin temperature exactly for any calculations. So here we've got minus 100 degrees, so we need to convert that to Kelvin. So minus 100, okay, times 273. Okay, so this is the equation we're going to use, and all the the figures, all these variables have been converted to SI-based unit. So that finally, if we get the result here, this must be SI unit as well, which is for the mass would be kilogram. Okay, so if we calculate this, and then we will get the ounce of 38.65 kilogram. So that's basically the mass of the nitrogen.